Hello, beautiful people, and welcome back to Unit 2 of Regents Chemistry, which is Atomic Concepts. Today, we will be talking about the isotopes. So, isotopes are just different forms of the same element. And the basic difference between these different forms of the same element is their number of neutrons. Because remember, they have the same number of protons. If it's the same element, it has to have the same number of protons. The only difference between them is the number of neutrons. For example, here we see three different isotopes of carbon. You see the atomic number at the bottom is the same for all three of them, is 6, which means all of them have 6 protons. But the number at the top, the mass number, is different, which means their number of neutrons is going to be different because mass number is number of protons plus neutrons. So if protons are remaining the same, then that means we are changing the number of neutrons. So there are two ways in which we write the isotopes. So here are those two ways. You can either just get like the symbol with the mass number at the top and the atomic number at the bottom, but sometimes you can also get the symbol slash the mass number. Please do not ever confuse this with the atomic number. Whenever you are given an isotope in this form, then that is that the number that you see with the symbol is the mass number, not the atomic number. Mass number is the number at the top, the number of the protons and the neutrons. Alrighty. So here we are looking at carbon again. We have the mass number at the top, which is, as you guys see, a decimal number. So it is representing an average of the masses of all of its naturally occurring isotopes. And here are those three isotopes. The first one, carbon 12, has 6 neutrons because 12 minus 6 is 6. The second one, carbon 13, has 7 neutrons because 13 minus 6 is 7. And then the last one, carbon 14, has 8 neutrons because 14 minus 6 is 8. So once again, as I said, they have the same number of protons, but they have different number of neutrons. So how do we calculate the average atomic mass, that decimal mass number that you see in the periodic table? So basically what happens is that there are so many elements out there that have isotopes, and their isotopes exist as a mixture, which means if you look at this example here, we have two different isotopes of chlorine. Chlorine 35 exists 75.76% in nature. Chlorine 37, on the other hand, exists 24.24% in nature. Now, because of this natural abundance and because of this ratio in which they exist in nature, we cannot just take their atomic masses and do like the regular adding and then dividing by 2 thing to find the average. Because that's how we normally take the average, right? You just take the numbers, you add them, and then you divide them by the total number of things that you have. But that's not how we can do that in this case because they have different percent abundances. So this is the procedure that we follow to find the average atomic mass. There are 3 main steps. Step number 1 is that you take the percent abundance and you convert that into a regular number. Like you get rid of the percentage part. So there are 2 ways you can do that. You can either just move your decimal 2 times to the left, or you can just divide the percent abundance by 100. Whichever way you choose to follow, you are basically just getting rid of the percentage and getting a decimal number. Now, once you have the decimal number, your next step is to multiply the atomic number for your first isotope with that decimal number of the abundance. Do the same with the second isotope. Take the atomic mass, multiply that with the decimal number for the for the abundance. If you have a third or fourth isotope, do the same for all of them as well. Get your answers for all of them. And then your last step will be to add those answers. So here's what it looks like. We have the same example for the 2 isotopes of chlorine. So when we start with chlorine 35, remember the first step is to convert the percent abundances into a non-percent form, get rid of that percentage. So let's say I'm just moving the decimal 2 times to the left, or in your case, let's say you're just dividing this by 100. So for chlorine 35, we get 0.7576. Okay, for chlorine 37, we get 0.2424. All I did was move the decimal 2 times to the left or divided this by 100. Now, we move on to step number 2 and step number 3. So step number 2 is we already have these percent abundances, right? So we take those percent abundances and we multiply them with the atomic mass. So let's first do that for chlorine 35. Here's the atomic mass and here's the percent abundance. I multiply both of them. And then I go ahead and do the same for chlorine 37. Here's the atomic mass and here's the percent abundance. I multiply both of them. And then your step number 3 would be to add your answers. Now, do not just go ahead and plug in all of this just like that in your calculator because you will have to take care of the brackets. So make sure to break this down in steps, okay? So let's do this multiplication first. This is the answer that I get. Then do that multiplication first. This is the answer that we get. And then we can go ahead and add our answers. So we get 35.452 atomic mass units, which is the average atomic mass for chlorine. Okay, so let's try that with this example for sulfur, where we have 4 different isotopes for sulfur. The first one is sulfur 32. Remember, our first step would be to convert the percent abundance into a regular decimal number, get rid of the percentage. So when I do this for sulfur 32, we get 0.9493. Do the same thing with the second one. So remember, it's just divide that by 100 or move the decimal 2 times to the left. We get 0.0076. Same thing for the next one, we get 0.0429. And same thing for the next one, we get 0.0002. Now that we have our natural abundances converted into just abundances, the decimal forms, we'll go ahead and multiply our atomic masses with the percent abundances. So here we do that for sulfur 32, then for sulfur 33, then for sulfur 34, and then for sulfur 36. And then our next step would be to add them. So remember, try to break this down, do this step by step so that you have a more precise answer. Or if you're putting this all together in your calculator, make sure that you're putting in proper brackets so that your calculator knows what you're trying to say. So here I'll go ahead and multiply the first one, do that for the second one, same thing for the third, and same thing for the fourth. And then we'll go ahead and add our answers. And this is what we get as the atomic mass for sulfur. Please do not ever forget your units. So AMU is the unit for average atomic mass. Alrighty, so that was it for this part of the unit. I will see you guys in the next one.